අයිබෝන් දුවපුතේ අද මම ඔබ හමුවට පැමිණීමට බලාපොරොත්තු වෙන්නේ මේ HND QS පාඨමාලාව යටතේ වන තවත් එක් වැදගත් මොඩියුලයක් වන කන්ස්ට්‍රක්ෂන් ටෙක්නොලොජි කියන එකට අදාළව යම්කිසි කරුණු කිහිපයක් ගෙන දක්වන්න. එතකොට මම මේට පෙරත් මේ කන්ස්ට්‍රක්ෂන් ටෙක්නොලොජි එකට අදාළව වීඩියෝස් දෙකක් කරලා තියෙනවා. එතකොට මොනවද බිල්ඩින් එකක්, බිල්ඩින් ටයිප්ස් මොනවද, ඊළඟට සස්ටේනබල් ඩෙවලොප්මන්ට් කියන්නේ කොහොමද, ඒ වගේ කරුණු කාරණා මේකෙදි කතා වෙලා තියෙනවා. ඊට පස්සේ අපි අද තුන්වෙනි මෙන්න මේකෙන් අපි බලාපොරොත්තු වෙනවා මේ කන්ස්ට්‍රක්ෂන් ටෙක්නොලොජි කියන මේ විෂයෙම තවත් එක් කොටසක් වන මේ සයිට් ඉන්වෙස්ටිගේෂන් එකක් කියන්නේ මොකක්ද කියන එක. කන්ස්ට්‍රක්ෂන් එක කරන්න කලින් ඒ වටපිටාව, ඒ කියන්නේ සයිට් එක ඉන්වෙස්ටිගේට් කරන මෙතඩ්ස් තමයි අපි බලන්නේ. ඊට අපි ඉස්සෙල්ලා බලමු ප්‍රොජෙක්ට් ඩෙලිවරි ෆේස් එක කියන්නේ මොකක්ද කියන එක. එතකොට ඔබට පේනවා මෙතන ප්‍රොජෙක්ට් ඩෙලිවරි ෆේස් it could be initiation, planning, execution, monitoring and planning, closure. These are the 5 steps. මේක ඇත්තටම ස්ටෙප්ස් 5කින් සමන්විත චක්‍රයක් ආකාරයට ක්‍රියාත්මක වන්නේ. එතකොට ප්‍රොජෙක්ට් එක ඩෙලිවරි ෆේස් එකේදී අපි ඉනිෂියේෂන් එකක් කරන මූලික කන්සෙප්ට් එක, ඊට ප්ලෑන් කරනවා එක ප්ලෑනින් ස්ටේජ් එක, ඊට පස්සේ එක්සිකියුෂන් කියන්නේ ඒක කන්ස්ට්‍රක්ෂන් එක රියල් සයිට් එකේ සිදුවෙන එකක්. ඊට පස්සේ ඒක මොනිටරින් කරන්න ඕනේ ඒ කන්ස්ට්‍රක්ෂන් නියමිත පරිදි වෙනවද කියන එක, සහ අන්තිමට එන් යූසර්ට අපි ඒක හෑන්ඩ් ඕවර් කරන එකක් තමයි මේ ක්ලෝෂර් කියන එකෙන් කියන්නේ. Okay, we will go each step deeper a little bit more. Okay, in the initiation, so as you can see, project initiation phase is defined in terms of its function, purpose, scope, size and economics. The success and failure of the project will be depend on how well the space is defined, detailed and managed. Important pre-design tasks are detail of the project's program, economic feasibility assessment, including the project's overall budget and financing, site investigation and selection, including the verification of the site's appropriateness and determining its designated land use. Government constraint assessment, for example, building codes and zoning constraints and other legal aspects of the project. Sustainability rating, whether the owner would like the project to achieve sustainability rating such as US Green Building Council, leadership in energy and environmental design, certification at some level. To select the design team, okay, these are the steps that we can identify at the initiation phase. So in this space, as you see, so we need to take some approvals and we need to consider about the design code such as British code or Euro code, and sustainability rating such as US Green Building Council or LEED. Okay, then we move on to the second phase of this project delivery life cycle, that is planning. Okay, before further go to this planning phase, we'll just go through some additional notes, including this stage. Okay, the site investigation. As you can see in this figure, suitability of site for proposed construction. Site investigation එකේ අපි බලන්නේ මේ suitability එක. මේ proposed construction එකේදී. දැන් මෙතන පේනවා මේ ඔබට මේ on your right hand side figure you can see there are 1 2 3 4 story building has to be constructed and single story building has constructed. Then the type of foundation to be construct according to each building is shown in this figure. It will depend on the structure, right? මේකෙදි අපිට පේනවා මේ ස්ට්‍රක්චර් එක අනුව කොහොමද මේක වෙනස් වෙලා තියෙන කියන එක. එතකොට මේ වම් පැත්තෙන් තියෙන බිල්ඩින්ග් අපිට පේන මේ තට්ටු 4ක මේ ෆිගර් එකේ බලන්න තට්ටු 4 උස බිල්ඩින් එකේ පයිල් ෆවුන්ඩේෂන් එක. ඊට පස්සේ යා පැත්තෙන් තියෙන දකුණු පැත්තේ තියෙන එකේ තියෙන තනි ස්ටෝරි බිල්ඩින් එකක්. එතකොට එතන පොඩි ෆවුන්ඩේෂන් එක. ඒ කියන්නේ පයිල් ෆවුන්ඩේෂන් එකක් නෙමෙයි. රාෆ්ට් එකක් ෆවුන්ඩේෂන් ඒ වගේ එකක්. ඒකත් මේකත් ඇතුළ වෙනවා මේ සයිට් ඉන්වෙස්ටිගේෂන් කියන එකට. ඒට අර ඉස්සෙල්ලා කියපු කරුණු වලට අමතරව. ඊට පස්සේ right. The soil exploration or geotechnical investigation is a part of site investigation. Geotechnical investigation එකක් කරන්න ඕනේ. දැන් ඔබට පේනවා මෙතන මේ ෆිගර් එකෙත් දක්වලා තියෙනවා මේක මේ පස්තර වෙනස් වෙන ආකාරය. ඒකට ඒකත් අපි මේකදී කරනවා soil exploration එක. In addition to that, we will see a definition. I have given some definition. The process of determining the layers of natural soil deposits that will underlie a proposed structure and their physical properties is generally referred to as site investigation. Importance of site investigation. Let us see why it is important. To assess the suitability of proposed site and the environment with the proposed project. Second one, to provide adequate information for design purpose with optimum cost, including temporary work. To plan for the best construction method. Fourth one, to predict and avoid delay during construction. Fifth one, to estimate possible changes to the soil profile, condition caused by construction of project. To suggest the suitability of alternative construction site if needed. Exploration program. Exploration program is to determine within practical limit the stratification and engineering properties of the soils underlying the site. The principal properties of interest will be the strength, deformation and hydraulic characteristics. The program should be planned so that the maximum amount of information can be obtained at minimal cost. Okay, now we will see methods or planning of site investigation. Desktop study. So you have to know these technical terms. So when you are working in construction site, okay, we will see the desktop study. It compilation of the existing information regarding the structure, collection of existing information for the subsoil condition. Second one, site reconnaissance. Site reconnaissance. Third one, detailed site investigation. Fourth one, laboratory tests such as index properties, consolidation test, direct shear test, triaxial test, unconfirmed compression test, etc. Fifth one, analysis of test result. Sixth one, preparation of site investigation report including geotechnical recommendation. Okay, now you will see what is desktop study. Introduction. This refers to the two studies carried out to research rather than physical investigation. This is the preliminary investigation carried out for the proposed project. This will be less time consuming and less expensive than the physical investigation. Initial understanding of the subject situation, potential risk and details, scope and methodology of subsequent investigation. Geological map and memories are probably most important sources of information, as these given an excellent indication of the sort of ground. For example, you can see for this Google Maps of the site. And aerial photography is another extremely useful source of information. Records of previous site investigation reports are also helpful in a desk study. Service records are also an essential part of the desk study. Site reconnaissance. The site reconnaissance phase of a site investigation is normally in the form of a work-over survey to the site. Information should be collected on the overall site layout, topography, basic geology. Local conditions should be examined, such as climate, stream flows, groundwater condition, site utilization related to weather and time of year. Possible photographic records should be kept. Important evidence to be checked. Hydrogeology, wet marsh ground. Marsh ground එක කියන්නේ වගුරු බිමක් වගේ කියන එක. Springs or seepage, ponds or stream and wells. Slope instability. The sign of slope instability show a bent tree, hummock on the ground and displays fences or drain. Mining. The presence of mining is often sign of subsidence and possibly discussed mine shaft. Open cast mining is indicated by diverted streams, replaced or removed fence, hedges line. Access. It is essential that access to the site can be easily obtained. Possible problems include low overhead cables and water course. විශේෂයෙන් අපි මේ access එක බලනකොට අධිබලති විදුරයන් වගේ ඒවා ගමන් කරන්නේ නැති තැනක් වෙන්න ඕනේ මේ සයිට් එක අපි තියෙනකොට. මොකද එහෙම වුණොත් අපිට ඒව ගැන කන්සිඩර් කරන්න වෙනවා. එහෙම වුණොත් අපිට වැඩ කරන්න අමාරුයි. ඒ වගේ ඉලෙක්ට්‍රිකල් ලයින්ස් වගේ ඒවා disturb වුණොත්. Soil exploration. Nature of soil, quality of soil we will explore. Attempt and understanding subspace conditions. Soil and rock profile for the construction substructure. Geological features of the region. Position and variation of groundwater table. Physical properties of soil and rock. Contamination, if any. General data of adjacent structures, hydrological data, topography, soil maps, seismicity, etc. Soil investigation. Why we do soil investigation? To predict possible geotechnical problems and devise relevant solution. To determine the types of foundation required for the proposed project at the site, that is shallow foundation or deep foundation. To make recommendation regarding the safe bearing capacity or pile load capacity. Okay, soil investigation. Determine bearing capacity for foundation, determine water resources, find aggregate deposits for road construction, estimate infiltration and seepage rates, access land use capability. So information required for site investigations are depth, thickness, properties of each soil layer, location of groundwater table, depth to bedrock. Okay, now we will see some images of some defects foundations. So foundation failures, as you can see in both images, the structures are collapsed. See, on your left hand side structures and right hand side structures, all the structures rather collapsed. Sinkholes, you see some gila basin mage වෙච්ච තැන්. Payment failures මේ වේදිකාවල් වල තියෙන failures නිසා වෙච්ච damages තමයි මේ වෙන්නන්නේ. Right. Soil exploration. We will see how soil exploration will be done. The three important aspects are planning, execution and report writing. Planning, to minimize cost of exploration and yet give reliable data. Decide on quantity and quality of geotechnical investigation. Execution, exploring subsoil, that is drilling. Conducting in situ test and obtaining soil properties in field. Collection of disturbed and or undisturbed soil samples. Laboratory testing on collected samples. Study of groundwater conditions. Sample collection for chemical analysis, followed by geophysical exploration. Report writing, description of site condition, topographic features, hydraulic condition, existing structures, supplemented by plans and drawings. You have to provide it additionally. A description of proposed construction, nature, type and loading arrangement, description of field activities, description of lab activities, analysis and discussion of data collected, preparation of charts, tables, graphs, etc., calculation performed, conclusion and recommendation. Okay, now we will see geotechnical design cycle. Geolaboratory soil testing, soil properties, then design office, analysis and design. Geotech report and soil sampling is a cycle, you can see. So practically impossible to explore entire area. Therefore, critical locations selected and explored. So in this soil testing, we can't do the area covering all the site, but instead we do some selected spaces, locations on the site and do the geotechnical, geolaboratory soil testing. So design office, analysis and design, geotech report generated, and soil sampling likewise is going as a cycle. Field activities. Field activities can be carried out other than the site recognitions for further investigation. So field activities, you can see backhoe, drill ring, trial pit. We can see some trial pits are constructed and This the depth of the trial pit could be 1 to 2 meter or 2 to 4 meter. Borehole, also do some borehole investigation. So 75 millimeter diameter and 10 to 30 meter depth එකට අපි borehole එකක් කරනවා. trial pit එකක් හෝ borehole එකක් කරලා clay මේ investigate කරන soil layers. That's a field visit, right? Then trial pits or trenches. Trial pits or trenches. This is a shallow excavation going down to a depth not more than 6 meters. The trial pits such as used extensively at the surface for block sampling and detection of services prior to borehole excavation. So this site investigation, so borehole excavation, this is how the trench, trial pits or trenches. Trial pits or trenches, you see in this image also, first layer, second layer, third layer, likewise the soil is stacked in a layer wise. Trial pits or trenches. Advantages: cost effective, provide detailed information of stratigraphy. Large quantities of disturbed soils are available for testing. Large blocks of undisturbed samples can be carved out from the pits. Field tests can be conducted at the bottom of the pit. Principles of stratigraphy. Principles of stratigraphy. Correlation, weather, water flow, cyclicity, preservation potential, accommodation, base level, incomplete record, funnel, biological succession, inclusion, cross-cutting, relationships, lateral continuity, original horizontality, superposition. Okay, disadvantages of trial pit. Depth limited to about 6 meters. May require site supports in coarse grain soil and soft clay. Grain soil or soft clay may need site support. Deep pits uneconomical. Deep pits uneconomical. Excavation below groundwater and into rock difficult and costly. Too many pits may scar site and require backfill soil. Time consuming, limited to depths above groundwater level. Boreholes. As in this, in your right hand side figure, you can see the locations where the boreholes are situated. For example, if we take A5, A5 is a BH tree, borehole tree. C2, that is borehole 1. And where is borehole 2? BH2 is situated in B4. BH5 or 5th borehole is located in D3. So likewise, there is all the boreholes are arranged in a grid so that each and every borehole location can be justified accurately. Practically impossible to explore the entire site. Building regulatory codes provide guidelines on the minimum number of boreholes and their depth. So the footprint of a structure should be divided using a grid approximately 20 to 40 meter for large area, and borehole should be located at node points on the grid. Incompressible soil such as clay, the boring should penetrate at least 1 to 3 times the width of the proposed foundation below the depth of embedment or until the stress increment due to the heaviest foundation load is less than 10%, whichever is greater. Preliminary plan of borehole location at site. The figure will show. Location and depth of borehole continued. In very stiff clay and dense coarse grained soils, boring should penetrate 5 to 6 meter to prevent that the thickness of the stratum is adequate. Boring should penetrate at least 3 meter into rock or 10 feet. Boring must penetrate below any fields or very soft deposits below the proposed structure. The minimum depth of borehole should be 6 meter unless bedrock or very dense material is encountered. Method of boring: auger boring, preferred for shallow depths, low groundwater table. Wash boring, high water table, deeper soil deposit. Rotary drilling, high quality boring, also for rock drilling. Precaution drilling, fast drilling. Hand auger, generally suitable for all types of soil above the water table, but suitable only in cohesive soil below the water table. Strings of drill rods is used for advanced in the boring. Maximum depth 25 meters. The diameter of holes vary from 100 to 200 millimeter. This method is not suitable for stiff to hard clay nor in granular soils below the water table. So you can see this how this hand auger is working. It's like a drill. So the hand tools are two types. Post hole auger in your left, see in your right hand side image, you can see this hand tools, that is post hole auger and helical auger, two types, right? So even in your left hand side image also you can identify that post hole auger is using the man at the very first appeared in this image, and the two men are working with helical auger, which is in the last image. Okay, hand auger you can see in the practical scenario. Advantages: cost effective, not dependent on terrain, portable, low headroom required, used in uncased holes, groundwater location can be easily identified and measured. Then disadvantages: depth limited to about 3 meter to 25 meter, labor intensive, undisturbed samples can be taken for soft clay deposits only, cannot be used in rock, stiff clay, dry sand, etc. Wash boring, hole is drilled, this is another method, right? Hole is drilled by driving a casing about 2 to 3 meter long and inserting drill rod with a chisel shaped chopping bit at the lower portion. Chopping bit, you can see in the your right hand side image also, you can see this chopping bit, direction of water flow and casing pipe. Okay, this water is pumped down. Hole is advanced by chopping action and jetting action. Chopped soil and water is collected in a tub. You can see these things in this picture. Okay, advantages. Cheap method does not interfere surrounding soil. Disadvantages. Finer particles such as clay, loam not settle easily. Large heavy particles may not brought up at all. Exact location of the material cannot be determined easily. Straight rotary drilling. Main cutting force. Power rotation of drilling bit. Circulating fluid. Remove cutting from hole. Advantages. Quick. Used in uncased holes. Uncased. Used in uncased hole. Undisturbed samples can be obtained quite easily. Groundwater location can be identified. This method also we can see some disadvantages. Cost of drilling increase with depth. Site must be accessible to motorized vehicle. Difficult to use in gravel or rocks. Precaution drilling. Used for making holes in rock, boulders and hard strata. You can see in this right hand side image also. Grinding the soil by repeated lifting and dropping of heavy chisels or drilling bits. Water is added to form slurry of cutting. Slurry removed by balers or pumps. Advantages. Quick. Used in unseized holes. Undisturbed samples can be obtained quite easily. Groundwater location can be identified. Disadvantages. Site must be accessible to motorized vehicle. Rate of progress. Action of the rod. Examination of cuttings into drilling fluid gives an idea of the encounter strata. Bentonite, Montmorillonite clay is the typically used drilling fluid. Bentonite stabilizes the boreholes, avoids soil caving. Borehole is washed to remove bentonite coating. Any water in the borehole is bailed out. Almost 24 hours given for stabilization of the groundwater table. Depth of groundwater table determined. In this image, you can see continuous flight auger drilling through caving materials. Okay, so today these are the things that I wanted to discuss with you. So we basically discussed in this section what are the project delivery phases, then the importance of site investigation and some drilling methods, some soil investigation techniques, and we have seen some images of failure structures of foundation, pavement failures we saw, sinkholes we saw, and soil exploration we identify. Then what is it? Geological design cycle we have seen, and field activities. They are backhole and drill rig, so trial pits and boreholes we have discussed, or trial pits, so sometimes trenches we call this. We have seen some their advantages and disadvantages, and borehole. Location and depth of boreholes we have seen. Location depth, that location and depth could be 5 to 6 meter. And we have seen some method of boring. There's auger boring, wash boring, rotary drilling, and percussion drilling. Having gone through that things, we have concluded this section. So I hope that you would get some idea of what is the project delivery phases and the importance of site investigation and method of site investigation. Likewise, there are lots of things that we have covered here. So regarding this lesson, so you may, having gone through this lesson, you may comment down below of the today's lecture. And also I have done some lessons which is related to construction technology sub module. So I have included these links for video, the previous videos rather, so that you can go and watch them as well. And also, if you think that you are beneficial for this video for your studies and knowledge, you may share this video with your colleagues and friends. Also, feel free to subscribe to the channel so that wherever whenever I uploaded a video, you may get a notification very easily. අද මේ මේකින් අපි ලෙසනින් කරේ site investigations කියන්න මොනවාද, ඊට පස්සේ project delivery plans ගැන, ඊට පස්සේ මේ boring methods ගැන කතා කරා. ඉතින් මේක ගැන ඔබේ අදහස් කියන්න මේ lesson එකෙන් අය පහතින් කමෙන්ට් කරන්න පුළුවන්. ඒකම මෙම lesson එක ඔබ HND පාඨමාලාවට අදාළව තියෙන construction technology module එකට අදාළයි. ඉතින් මේක ඔබට ඔබ HND කොන්ටෙක්ස්ට් සර්වින් කරනවා නම් මේක ප්‍රයෝජනවත් වෙනවා. ඒකම ඔබේ දැනුමට ලබා ගන්නත් ඕනම කෙනෙකුට නරඹන්න පුළුවන්. ඉතින් මේ වීඩියෝ එක විනෝන ඔබේ අදහස් පහතින් කමෙන්ට් කරන්න. එක්කම ඔබේ අංශයක් මේකෙන් ගත්තනම් ඔබේ යාළුවෙලින්ටත් මේ වීඩියෝ එක ෂෙයා කරන්න අමතක කරන්න එපා. එක්කම channel එක subscribe කරලා තියන්න. එහෙම වුණොත් අලුතෙන් වීඩියෝ එකක් දාපු ගමන් ඔබට notification එකක් එනවා. ඉතින් අද පාඩමේ මේ පමණයි ගෙනීමට බලාපොරොත්තු වෙන්නේ. අපි නැවත වරක් මෙම යුනිට් එකට අදාළවම තවත් ලෙක්චර් එකකින් හමු වෙනතුරු ඔබ සැමට සුබ දවසක් වේවා. ආයුබෝවන්.